Hey there, science fans! Today we're diving into the wacky world of static electricity. Buckle up because this is electrifying stuff. It all began with a dude named Thales from Miletus, way back in ancient Greece, think 600 BC.
Thales realized that if you rubbed amber, a fossilized tree resin, with fur, something strange happened.
The amber would attract light objects like feathers or hair. Whoa, it was like magic, but Thales knew there had to be a scientific reason.
He called this mysterious force electron, after the Greek word for amber.
Little did he know he'd just stumbled upon one of nature's coolest phenomena, static electricity. But here's the thing, figuring out exactly this happened would take thousands of years and a whole lot of head-scratching by some of history's brightest minds. Fast forward a few centuries and humans were still rubbing things together and watching sparks fly. We became masters of static, but understanding it, that was a different story.
Medieval scholars called it amber's virtue, which sounds more like a superhero power than a scientific principle. But hey, they were getting there.
Then came the Renaissance, a time of great scientific awakening. Folks like William Gilbert, Queen Elizabeth I's personal physician Fancy, started doing some serious experiments.
Gilbert discovered that amber wasn't alone. Lots of materials could be electrified by rubbing. He even coined the term electricus to describe this attractive force. Progress.
But the big question remained, what was actually going on? Why did rubbing certain things together create these mini lightning shows? The mystery deepened, and scientists were just getting started. Fast forward again to the 18th century, where we meet the one and only Benjamin Franklin. Now, Ben was a busy guy, founding father, inventor, postmaster general, you name it. But he was also a bona fide science geek, and static electricity was his jam.
You probably know the story of Ben flying his kite in a thunderstorm. Talk about a risky experiment. But it led to a major breakthrough, the understanding that lightning was just a giant spark of static electricity. Brilliant.
Franklin also figured out that electricity wasn't a single fluid, but involved positive and negative charges. He even coined the terms. But even Ben, with all his genius, couldn't fully explain the nitty-gritty of how these charges worked at the atomic level. That mystery would have to wait for the quantum revolution. Section 4. Modern Marvels. Unmasking the electron's dance. Now let's jump into the 20th century where things get really interesting. Thanks to the mind-blowing discoveries of quantum physics, we've finally unlocked the secrets of the atom.
Turns out it's all about tiny particles called electrons. You see, everything around us is made of atoms, and those atoms have even tinier particles whizzing around inside them. Electrons have a negative charge and they love to move. When you rub certain materials together, like that amber and fur, you're basically giving those electrons a one-way ticket from one material to the other. The material that gains electrons becomes negatively charged, while the one that loses them becomes positively charged. And since opposites attract, those materials become drawn to each other. Boom! Static electricity.
Section 5. Static in action, from balloons to photocopiers. So, now that we've cracked the code, what can we do with this knowledge? Turns out, static electricity is more than just a party trick with balloons and your hair. It's everywhere.
Ever get a shock touching a doorknob in winter? That's static discharge. Static electricity is also hard at work in all sorts of cool technologies. Photocopiers, for example, use static electricity to attract toner particles to paper, creating images. Air purifiers use it to trap dust and allergens. And in some high-tech applications, static electricity is even being used to develop new types of batteries and energy storage devices. Who knew something so seemingly simple could be so powerful?
Section 6. The future is electric and less staticky, hopefully. So there you have it, folks. The mystery of static electricity, solved after thousands of years of human curiosity and scientific exploration. From ancient Greeks rubbing amber to modern scientists unraveling the secrets of the atom. It's been a wild ride. And who knows what amazing new discoveries the future holds. Maybe we'll finally figure out how to harness static electricity to power our homes or create those flying cars we were promised. Or maybe we'll just have to settle for less static cling in our laundry. Either way, it's an electrifying time to be a science enthusiast. This video is for entertainment purposes only. Thank you for watching. Please share, like, and subscribe.